Happy Tuesday to you. Today, quick notes about problem solving, majority with using a formula. Oh, I got to stay back here because then I'm in the light. I come over here and I'm in the shade. Okay, all right, so quick notes on that. And then there will be some homework problems to go along with it off of this week's worksheet. So let's dive into it. Remember, we're going to be dealing with word problems a lot in this particular section. Read the word problem, reread it to make an equation, or in this case, a lot of times this case is to use a formula to figure out what goes into the formula, and so on and so forth. Okay. Then we're going to solve it because we're going to be missing one key component. And then in this one, for sure, the check is, does my answer make any sense dealing with this particular problem? Okay. When you're using a formula, I find it easiest to write the formula down first, unfilled in. So basically write what the formula is. So if it's a crazy formula, let's say the area of a trapezoid. Area equals 1/2 base times height times the sum of the two bases. So actually write the formula down. A equals 1/2 height times base plus base. Okay? Actually writing it down just like that without anything else in there. Then, next step, go in, plug in your values. Okay? Makes it be a little more clearer in your work, keeps the mind clear when you're doing the maths, and then going through and solving, and then checking to make sure it makes sense. Okay? So, let's try some here now. First one, distance equals rate times time. Great simple formula for you. D equals R times T. We're going to ask you to find the missing variable. D equals 300 miles. R is we don't know. And T equals 4 hours. Okay? So I would start with D equals R times T. That's my formula. Okay? It's right up here. So I'm going to use it. There it is. Now I can fill it in. My distance is 300. My time is 4. But my rate is, I don't know. So let's call it, actually tap the brakes. Let's be smart. And let's call it R. I was about to call it X, but let's call it R because that's what it is. And now we're solving for it. Okay? So 300 equals R times 4. So then that is going to be, I'm going to divide both sides by 4. Okay? And when I divide both sides by 4, I get 75 here is my R value. Sounds great. Sounds grand. Sounds wonderful. Okay? So then when it goes to my answer now because we have labels in our problem, and all of our ones tonight will probably have some kind of a label, we're going to have to, let's first get this screen, put that up in the corner up there. Okay? And so the label here then would be 75. In this case, this was miles here. Actually, I used that one. Miles, and 4 was hours. So that's miles over hours. So you could leave it like that, or you could write it as miles per hour. As our answer. Now, does that make sense? Is it logical for something to be going 75 miles per hour? Yes, it is. Most of you have probably even driven at 75 miles per hour if you've ever sped down to on I-39 at some point in time in your lives. Okay? And that's it. Works out. Moving on. Okay? Oops, now I got to bring down this. Oh, now it's all up in our grill. Now we'll put it back down here. Actually, we'll put it right here because then I can still use my colors. Matt Kenseth, who is Mrs. Linsmeyer's all-time favorite NASCAR driver because he's from Wisconsin, raced 600 miles at Charlotte, North Carolina in 3.5 hours. If D equals R times T, what was his average speed? Okay, well, D equals R times T is our formula that we're going to use. The distance that he traveled was 600 miles. We are looking for his average speed. That is our R, our rate. And the time it took him was 3.5 hours. Okay. So now what we're going to do is we are going to divide both sides by 3.5. Okay. And what I get is I get 171.428571. Okay. Which, all right, that's okay, because we're talking about the average speed of a race. Okay. So that again would be miles per hour. So I would say here that our rate would be 171.429 miles per hour. Now, you're going to say to yourself, Linz, you told us last week you don't like decimals. And your answer is, yes, I don't like decimals. However, when we're talking about miles per hour, I'm not going to say 6,000 over 35 miles per hour. I would say 71.4 or 71.43 or 71.429 miles per hour. Okay? So that answer makes more sense than, what would it be? 1,200 over 7 would be the reduced fraction there. Okay? So, all good. Okay? Example number 3. This is just kind of a word problem and problem solving. Okay? You are hanging 3 pictures on a wall in your home that is 16 feet wide. The widths of the 3 pictures are 2 feet, 3 feet, and 4 feet. You want the space between the pictures to be the same, and for the spaces to the left and right of the group of pictures to each be 6 inches more than the space between the adjacent pictures. How should you position the pictures? Hoy! Whew! That's a lot of words in the maths. Okay? So, probably one of the better things for you to do, and you can do at any point in time that it's applicable, is it might help you to draw a picture of the situation. So what you're doing is you're looking at a wall. And on that wall, we're going to hang 3 pictures. Okay? So it's going to look something like this. Okay? Now, we can fill in what we know. We know that the width of our wall is 16 feet. We know that one of our pictures is 2 feet wide. And I get it that these are not to scale, but it's okay. One of our pictures is 3 feet wide. And one of our pictures is 4 feet wide. Okay? We know that. We want the spaces between the pictures to be the same. So let's call that X. Because we don't know what that space is going to be. And the spaces to the left and the right, so this space here and this space here, to be 6 inches more than the space between the adjacent pictures. So that means that this is going to be X plus something. And this is going to be X plus something. Now, one thing that pops out for me is that here we were dealing in feet, here we were dealing in feet, but here, we're not in the same dimension. We're not in the same units, I think, would be a better way of saying it. So we need to come up with a unit. So I can either convert all of these feet, these green feet, into inches. That would be legal. Or I can convert 6 inches into feet. And I think that that is an even better thing to do, because 6 inches is half of a foot. So here it would be plus 0.5, and here it would be plus 0.5. Okay? And now we're in feet all the way through. Okay? So now we need to come up with an equation based off of this. Well, I know the entire width of my wall is 16 feet. And if I start over here on the left side, I would go X plus 0.5. And now I am to here. And then I would go plus 2. And now I am to here. And then I would go plus X. And now I am to here. And then I would go plus 3. And now I'm to there. Plus X. Now I'm to there. Plus 4. Now I'm to there. Plus X plus 0.05. And now I'm all the way across. Okay? So there is my equation. Now we can simplify it a little bit. Let's clean up this whole right side thing. So 16 here equals, we've got 1, 2, 3, 4 X's. We've got 0.5, 2.5, 5.5, 9.5, 10. 2 plus 3 is 5, plus 4 is 9, plus the half over here, plus the half over there gives me 10. Okay? So now I can subtract 10. That gives me then 6 equals 4x. Divide both sides by 4. And that gives me 3 halves equals x, which is also 1.5. Okay? Because we're dealing with feet, okay? So x then is going to be 1.5 feet. Okay? Now the question was, how should we position the pictures? So we would position the pictures pictures should have 1.5 feet between them. And 2 feet, because it's x plus 0.5 on the outsides. Okay. And that would be how we would position the pictures. Just an answer of 1.5 feet there does not answer the question. The question is, how do we position the pictures? Okay? It always helps after you get an answer to go back into the problem and reread that last sentence where you figure out what you're going to need to find for that particular problem. Okay? That's it for this notes. Now I will tell you that you can do numbers 1 and 2 from the worksheet for this week, and that worksheet will be due Sunday night. Have a great day.